Alright, so we've got another question from Advanced Mechanics. This is quite a straightforward one. This is a concept question. So we're asked, why do we assume the trajectory is a parabola? So when we look at an object, if we draw a graph, let's say it launches from here, every time we're doing these calculations, we're assuming that it looks pretty much like this, and that this is exactly a parabola. So I should draw this a little bit more carefully. It goes up and then it comes down. We assume it's perfectly symmetrical, right? And this is, in a nutshell, for ease, right? So the answer to this question is it's easier to do the calculations if the trajectory is a parabola. If we were to factor in other considerations, it would depend on the circumstance. So for example, if you were factoring in wind or fluid resistance, you would get a slightly different looking parabola. You would get something that went up and then you would find that it cut off very quickly. The curve in purple is sometimes known as a ballistic curve. So this is what we sometimes call a ballistic curve. And a ballistic curve is a parabolic trajectory which factors in quadratic air resistance, or at least some resistance. These curves become much more complicated to model. So when we're doing these simple calculations, if we assume that the drag, the air resistance, is relatively minor, we're going to get a pretty good estimate anyway. So if we draw another curve here, I'll do this curve in yellow. We'll draw a curve that runs up here and then sort of goes down like this. This yellow curve is also a ballistics curve. The yellow curve and the red curve have a very similar X-max. They have a very similar Y-max. They will take a very similar amount of time. Right? So what this means is if you have relatively little drag or resistance or any other forces affecting the trajectory, you will find that the real curves that model the trajectory are so close to the parabola that you are pretty much getting the correct answers either way. So why do we assume the trajectory is a parabola? It's easier. If we didn't, it would be much more complicated to model these kinds of physics problems. And this is the answer we want to this question.